Okay, guys. Happy Sunday to you guys. My name is Delzi. We are about to start off the practicals. The previous video was basically an introductory part, and also to get us acquainted with the apparatus and equipment we're going to be making use of for the experiment. Okay. I have here with me, although the liquid is actually quite very small. This is a remainder from the last practicals. So this is ethanol. Okay, and this is distilled water, but I had to empty this container into my measuring cylinder, so I have some distilled water inside here. Okay, basically my reagents are quite very small. The main purpose of this video is just to teach us the steps and the procedures. Okay, I had conducted this experiment 2 to 3 times in the normal lectures, so this particular video session is just to get us acquainted and to expose to us how you're going to carry out this experiment in the lab. Okay, now here I have my table where I'm going to be recording the values I'll be getting from this experiment. Now, the first, for those persons that have the manual, the first procedure for this particular experiment is, they said, from the graph of density of water versus temperature, obtain the density of water at the laboratory temperature. Now, if you look at this, if you look up here, now the temperature of this particular value they'll give to you guys in the lab, they'll give it this particular guy in the lab. Now the temperature is 25 degrees Celsius, okay, and then the density is 1 gram per cm cube, 1 gram per cm cube, and of course we have 25 degrees Celsius. Okay, so in this case now we have this as the temperature and you have this as the density of the water, but do not forget that mil, because they could decide to change the unit of the density to gram per mil. Mil is the same thing as centimeter cube. Okay, so take note of that. Now the next procedure here is calibration of volumetric flask. Now, what is the sole aim of carrying out calibration? Calibration is basically to confirm if the volume we were told by the manufacturer is truly the volume that this guy will contain. Now, it's just like you going to an ATM machine and then you actually make withdrawal and the ATM machine brings out 10,000 naira. A typical Nigerian wouldn't just walk away with that 10,000. Do you get? The person will have to recount and be very sure that that money is 10,000, even if it's actually not right in front of the machine, but it could just be at the side. So calibration basically to confirm if what you're being given to is truly correct. So in the case of this flask, we were told that this flask is 10 mil. Okay, so we just want to verify if truly this guy is 10 mil. Okay, now every flask measuring cylinder or every measuring apparatus will always have a mark. So there is a mark here. I don't know if you can see that mark. If you look closely, let me see if we can see it. If you look closely, you will see a line here. That line is actually the mark. You see the line? Make it be like this. You see this line? Okay. Now, that is where this guy is actually going to stop. So, for us to calibrate this, you have to weigh this when it is empty, because at the end of the day, we are going to, from the procedure here, let me read the procedure. They said, under calibration of volumetric flask, you are to weigh the flask when it is dry. This flask now is dry, and you are to reweigh the flask again when you must have filled it with distilled water. Now, we had earlier done this, but remember I told us, okay, not in this particular video, I told us in class, was it in class or, but now I've mentioned that in the lab, I realized that they gave them the cover. I have a cover to this, but unfortunately I can't really find it. I don't know where I kept it. All right. Now, if you're being given the cover, ensure you weigh this with the cover, because if you don't weigh this with the cover, the answer you're going to get, and imagine not weighing this guy with the cover, and then after adding liquid, you weigh it with the cover, is definitely going to give you discrepancy in the answers. So I don't really have the cover here, but in the lab, they will give you a cover. So I had to weigh this guy. I weighed this guy first when it was empty, and I got 12 grams. But remember, in the lab, this would likely be greater than 12 grams since they will ask you guys to weigh with the cover. So I got 12 grams when this guy is empty. Alright, I had to fill this flask to the mark. After you must have weighed this when it is empty. Right, remember we're still under the process of calibration of this flask. We had to weigh this guy when it is empty, and then we have to refill this guy with water again to this mark and weigh it. Okay, so I'll pick up my measuring cylinder. You could decide to not use measuring cylinder, you could decide to use pipette, but just to be a bit fast. So I will just transfer the liquid from this water. I'll transfer this guy from this. I'm sorry. Okay, so and I've already done this procedure, but I just want to do it so that you guys will see it. After which I'll place it on my weighing balance. It gave us 22 grams. Okay, 22 grams. Remember, in the lab, the value most likely will be greater than 22 grams because there will be cover here. There will be a cover here. Do you get? So the cover, of course, will add to the weight of this. So the reason why we are getting 22 is because this guy doesn't really have a cover. But inside the lab, they'll ask you to do it with the cover. Alright. So you write this here. Now once you've completed this particular procedure, you can now solve for the density of, you can now solve for the volume of this. Now remember, let me solve it at this right side of the board. But I'm still going to clean it up afterwards. Now, density is equals to mass over volume. Now, the volume of this flask is actually what we want to find, because that's the main purpose of carrying out this calibration of volumetric flask. If you make volume subject of a formula, volume becomes mass over density. Now, how do we know the mass of water inside this flask? Remember, we had earlier weighed this when it was empty, when there was no water inside. We got 12 grams. We had to fill in water up to this mark again, and we weighed, we got 22 grams. So the mass of water inside will now be the mass filled with water minus mass empty all over density. Okay, so in this case now, remember from this formula, density equals to mass over volume. The density of the liquid, which is water in this case, we already know the density of water. It gave us from that first procedure to be 1 gram per centimeter cube. Volume of the flask is actually what we are solving out for, because we do not know the volume. That is the purpose of carrying out this calibration. Remember, we stopped at where there's a mark here. Okay, afterwards, the mass of this water. How do we know the mass of water present inside the flask? We're going to say the mass when it is empty, when it is filled, and we got 22, minus when it is empty, we got 12, all over density of water, which is 1. So when you now do that, you now say the volume of flask equals to 22 minus 12 all over 1. This becomes 10 over 1, which is 110 cm cube, or 10 mil. So the volume of this flask, from our calculation, we are getting 10 mil or 10 centimeter cube. Remember, centimeter cube is the same thing as mil. Now, recall that I told us earlier that they said this flask is 10 mil. So we've actually carried out our calculations and we've verified that truly this guy is 10 mil. So what this simply means is that anytime I carry out further measurement, anytime I pour in liquid into this flask up to this mark, I could equally say that is 10 mil because I've verified that this guy is truly 10 mil. Okay.